Hey class, in today's lesson we're going to talk about the fundamental theorem of algebra, which is found in section 5-6 of your book. Our objective is to use the fundamental theorem of algebra to solve polynomial equations with complex solutions. Alright, so the fundamental theorem of algebra comes from Carl Friedrich Gauss, who was a German mathematician. And basically the theorem says if a polynomial function of degree n is greater than or equal to 1, then the function when set equal to 0 has exactly n roots, including multiple and complex roots. So basically the degree or the highest degree of your polynomial is the exact amount of roots that you will have for your equation. So let's go through that. So in example 1, it says, what are all the roots of the polynomial equations below? So the first thing you need to understand is that the leading term has a highest power of 5. So if the highest power of 5, then that means that there will be 5 roots. All right, so let's figure out what those 5 roots are. The first thing we need to do, we have the highest power, since it is to the 5th power, we're going to have to use P over Q to kind of help us narrow down our choices. So remember, P is going to be 4, Q is 1, so the factors of 4 are 1, 2, and 4. And let me write this a different way. It's really 1 times 4 and then 2 times 2, but I'm not going to repeat 2, okay? And then Q is just 1, so the possible roots, and let's be specific, the possible rational roots are plus or minus 1 over 1, plus or minus 4 over 1, and plus or minus 2 over 1. And I really should have put 1, 2, 4, but it doesn't matter. All right, so what we're going to do is we're first, just like we've done before, we're going to test positive 1 and see if it fits. So we're going to test x equals 1. Okay, if that works, we can kind of move on from there. So let's take a look. If 1 works, I can put this into synthetic division. So then I write my coefficients. So 5th power is 1, 4th power is negative 1, 3rd power is negative 3, 2nd power is 3, 1st power is negative 4, 0 power is 4. Okay, you always bring down the 1 to start it off. So 1 times 1 is 1, that's 0. 0, negative 3, 0, 0, negative 4, 0. So that makes our equation x to the 4th plus 0x cubed minus 3x squared plus 0x minus 4. And that is our new function. Now, based on that new function, right, at least we know that x equals 1 is one of the roots, okay? But we've got to keep going. Some other roots. And when I say x equals 1 as a root, really I should write it as a root, so that would be x minus 1. So really that's what we have. All right, so if I keep going, and I should probably list it up here, x minus 1. Okay, that's one of them. Now from here we have to break down x to the 4th minus 3x squared minus 4. Okay, and the only way we're going to be able to do that is we have to kind of use substitution. So remember, we can actually say that a is equal to x squared and rewrite that. So technically this is a squared, right, minus 3 times a minus 4. Okay, if I continue with that process, AC is going to give me negative 4, and the factors of negative 4 that are going to work are negative 4 and positive 1. That would be AC. Okay, so that's going to end up looking like a minus 4 and a plus 1. I'm kind of working backwards here, so really that function, if I replace a back with x squared, I'm going to get x squared minus 4 and then x squared plus 1. All right, now this x squared minus 4 right? That's really difference of squares. So those roots are going to be x plus 2, x minus 2. That's difference of squares. So now we found two more, so they're going to go up here. X plus 2, x minus 2. All right, one more piece. We've got to break down x squared plus 1, and the only way that we're going to be able to break down x squared plus 1 is by doing the quadratic formula. And actually, I don't even have to do the quadratic formula. I can just set x squared plus 1 equal to 0. So if I subtract 1, I'm going to get x squared equal to negative 1, and if I take the square root, x will equal plus or minus I square root of 1. And so as a root, that would be, or actually let me get rid of the square root of 1, it's just plus or minus I. So as a root, that will look like x plus I and x minus I. So those are all 5 roots of that polynomial equation. And let me move further on to say that technically at the top, these are not our 5 roots, these are our 5 factors. And so then the roots of those factors would be 1, right? Positive 2, negative 2, I, and negative I. So those are the 5 roots, and that's an I. Okay, let's do this again on the next screen. All right, so it says, what are all the roots of the polynomial equation below? Okay, so to do that, we need to put everything in standard form first. So that would be x to the 4th plus 2x cubed minus 13x squared plus 10x equal to 0. Okay, in order to deal with this problem, we do have a greatest common factor, so we want to take out our greatest common factor, which is x. And so then we're left with x cubed plus 2x squared minus 13x plus 10 equal to 0. Okay, so since x was a greatest common factor, it's actually a root. So we have x equal to 0 as one of our roots. Now, by the way, don't forget, we're supposed to have 4 roots here because it's to the 4th power. Okay, so one of them is x equals 0. All right, we're going to keep going. So if 0 is a root, now based on this center part, we can do p over q, right? P over q. So the factors of 10 are 1 and 10, 2 and 5. And they are over 1. So the possible rational are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. All right, so I like to test the small number first. So we're going to try x equals 1 and see if it works. Okay, if x equals 1, then that means 1 would go in the box for synthetic division, and the rest of those powers, x cubed, the coefficient is 1, then x squared is 2, x is negative 13, and no power, or the constant, is 10. Bring down the 1. 1 times 1 is 1, that's 3. 1 times 3 is 3, negative 10, negative 10, 0. So that equation is going to be x squared plus 3x minus 10. And that should work. And by the way, since the remainder is 0, x equals 1 is also a root, so 1 is going to work. And then from here, we can do AC. AC is going to give us negative 10, and the factors of negative 10 that work for 3 are 2 and 5, specifically negative 2 and positive 5. So since those work, those factors would be x minus 2 and x plus 5. So that means that their roots are 2 and negative 5. So we have all 4 roots, and we are done. All right, in example 2, we're still technically following the same process, except what you'll notice is now we're going to start running into complex or imaginary solutions. So here we go. we will first start by So we'll first start by finding the real zeros on a calculator. So in other words, to do that, you can type that into your calculator and check to see where the equation is going to cross the x-axis. And basically, wherever it crosses the x-axis is going to be considered a zero. And so when you do that, what you'll notice is that your zeros, or your roots, same thing, right, are going to be 3 and -3. So remember, in total we need 4, based on the fact that that's to the 4th power. So if 2 of them are 3 and -3, we can start breaking down this equation using synthetic division as those being 3 and -3. So we'll first start with it breaking down this polynomial function with the 0 of 3. So here's 3. Then I'm going to write my coefficients. So to the 4th power is 1, 3rd power, 2nd power, 1st power, no power. 1. 3 times 1 is 3, 4, 12, 5, 15, 6, 18, 0. And that makes sense for this to be 0 because that once again proves that 3 is a root. So then that new equation becomes x cubed plus 4x squared plus 5x plus 6. Okay, then from there we're going to test the next root, which is -3. So here we go, -3. And its coefficients are 1, 4, 5, and 6. So drop down the 1. That gives me -3, 1, -3, 2, -6, 0. So that equation becomes x squared plus x plus 2. Now, at this point, we can't just keep breaking it down. In fact, what you'll notice is we can't do AC here. We have to use a quadratic formula. Just as a reminder, quadratic formula is x equals -b plus or minus the square root b squared minus 4ac all over 2a. Okay, so when we do that, we're going to get -1 plus or minus the square root of 1 squared minus 4 times 1 times 2 all over 2 times 1. So that'll be -1 plus or minus the square root of 1 minus 8 over 2, which is -1 plus or minus the square root of -7 over 2, which lastly becomes -1 plus or minus I square root of 7 over 2. Now, since it's plus or minus, don't forget that those are two separate answers. So one of the answers, and we can't reduce it, one of the answers is -1 plus I square root of 7 over 2. And the other one is -1 minus I square root of 7 over 2. And so our 4 roots have been identified. Let's do this last problem as our try. All right, so we have 2x to the 4th minus 3x cubed minus x minus 6. And either we can try to start by finding our real zeros on the calculator, or we can try doing p over q. And personally, I think it might be easier to at least try it on the calculator. So if we try graphing that, that's 2x to the 4th minus 3x cubed minus x plus 6. Nope, minus 6. And when I graph using the calculator, what I realize are that my zeros are -1 and +2. And remember, there should be 4 roots. So far, my calculator is stating -1 and +2. So let's check and see if -1 is actually a root. So if it is, I should be able to use synthetic division and it should work out just fine. So 4th power, 3rd power, 2nd power, 1st power, no power. Here we go. If I multiply as -2, -5, multiply as 5, 5, -5, -6, +6, 0. That works. So then our equation is 2x cubed minus 5x squared plus 5x minus 6. All right, that one works. So -1 works. So let's continue with 2, and hopefully that one will work also. So 2, and then those numbers, those coefficients are 2, -5, 5, -6. So 2 and 2 is 4, -1, -2, 3, 6, 0. That one also works. So I get as a function 2x squared minus x plus 3. Okay. From there, we can see if we can do AC. Let's see. AC would give you 6, and the factors of 6, 2 and 3. Let's see. If you try to do 2 and 3, that would have to be -3 and +2, and that's not going to work because it's not going to give you 6. So at this point, we have to do quadratic formula. So if I start trying to substitute that in, that'd be x equals -1 plus or minus the square root of -1 squared minus 4 times 2 times 3 all over 2 times 2. If I keep going, that's going to be 1 plus or minus the square root of 1 minus 4 times 2 is 8. 8 times 3 is 24 over 4. Keep going. 1 plus or minus the square root of -23 over 4. And lastly, 1 plus or minus I radical 23 over 4. So the other two solutions are, and we need to break them apart. One of them is 1 plus I square root of 23 over 4. And the other one is 1 minus I square root of 23 all over 4. And so these are our 4 roots. Guys, we are done. If you have any questions or need any assistance, come see me for tutoring.